Hello students, today we are going to learn how to generate the probability density function of a Gaussian distribution using a Octave. So Gaussian distribution is also called as normal distribution and it will be in a bell-shaped curve and most of the values are near to the average and only fewer values are away from the average, and this distribution is very important in engineering, especially in communication system and also for the noise analysis. Now let us understand the basic concept of mean and standard deviation using some real-time example. Here you can see the two graphs. One is narrow curve, other one is wide curve. And you can see here the mean value which I have given here written is both are 60, but the shape of the graph is different. Why so it is? Because you can see here I have taken the value of I have taken value, or the consider it has the marks of a student that is scored, that is 58, 59, 60, 61 and 62. Now I want to find out the average of these marks, that is 58 plus 59 plus 60 plus 61 plus 62 divided by number of students. So you'll be getting the value as 60. This is nothing but the mean value or the center value, right? So that is called as mean. The average marks or the center value is called as mean. Now I have to find out the deviation of the marks from this mean marks, right? So if I take 58, what is the difference between this number? -2. If I take 59, difference is -1. 60, obviously it is 0. 61, it is 1, and 62 is +2. You can see here the deviation is very less. All the values lies close to the mean value. Because of that you are getting a narrow curve. But in this case you can see here the value is 20, 40, 60, 80 and 100. If I add or take the average of it, 20, 40, 60 plus 80 plus 100 divided by 5, you'll be getting the mean value of 60, right? So the mean value is again 60, but here if I check the difference between the mean value and the data value, so it is 20 minus 40 minus 20, 0, 20 and 40. The deviation of the marks is more from the mean value, so I'm getting the wider curve here. So this is the meaning of the mean and standard deviation. That is, mean is center of the data, whereas standard deviation tells us the shape of the curve, that is, it decides the shape of the curve. And in case if the curve becomes more mean and flat, that means the standard deviation is very large. Once again I'll repeat, the mean decides the center, but the standard deviation decides the shape of the curve. And using this concept we will be understanding the Gaussian distribution. The probability density function of a Gaussian is given by 1 divided by root of 2 pi sigma y exponential of minus y minus mu y whole square divided by 2 sigma y square. And this formula helps us to calculate how likely a value is in the distribution. Here the formula can be divided into 4 parts. First part is this one. This is nothing but the constant part which ensures that the total area is equal to 1. That is, area under this curve, that is area under the curve is equal to 1. And here this formula, that is y minus mu y whole square, is nothing but distance from mean, that is how far the value is from the average. That is, if I consider this example, here you can see the mean value is 60, and if I take 70 as a value, that is what is the deviation from the mean value, that is given by the formula y minus mu y whole square. And this exponential part which is present here will tell us as the distance increases, this value will decrease. So this is the formula of the Gaussian probability density function. By seeing the graph or by seeing the formula, you can tell what is the peak value, that is peak at the mean 0, symmetric on both sides, and also area under the curve is equal to and the mean gives the center and the standard deviation controls the spread of the curve. And if I take a special case, that is normalized Gaussian, or it is also called as standard normal, that is this special case when it is applied when the mean value is equal to 0 and variance is equal to 1. So in this above equation you have to make the variance has equal to 1 and the mean value has equal to 0. So you'll be getting this normalized formula of Gaussian. Okay, so using this formula we'll be writing the code to generate the Gaussian probability density function, and you got to know how the graph will appear for the Gaussian probability density function, and what is the mean value and what is the standard deviation, and how to calculate those in the Gaussian probability density. So the shape of the curve is coming from the equation, this equation coming from this equation, that is exponential. As the distance increases, the square increases very fast, so the negative exponent becomes large and exponential becomes very small. That means what? Here I have taken some example. Here this is the formula of what? Distance from the mean, right? So if I consider mu, that is y has mu, it will be mu minus mu y whole square, which is equal to 0. So exponential of 0 is nothing but 1. So at mean value I'll be having a maximum peak. As you move away from the mean value, the value decreases because I have considered this y value as 0. So exponential of minus y minus mu whole square will be, so it will be 0 value. If it is e to the power of 0 1, if I take e to the power of 1, it is 0.37, e to the power of 4 0.135, e to the power of 9 it is 0.00767. So as you move away from the mean value, the value start decreasing. So this is why you are getting this type of curve, which is bell shaped curve. Now we'll write a code using a Octave, and we know the equation for the Gaussian probability density function, which is given by 1 divided by root of 2 pi sigma exponential of minus of y minus mu whole square divided by sigma to sigma square. So this is the formula for the Gaussian probability density function. If I consider the normalized Gaussian function, then I have to consider mu is equal to 0 and sigma is equal to 1. Now in this equation you can see what are the variables that is present, that is one is sigma and other one is mu. These are the two variables that I have to define before writing in the code. So I have written as mu is equal to 0, sigma is equal to 1. I have considered 0 and 1 because I am considering the normalized Gaussian plotting. Now x is equal to line space minus 5 comma 5 comma 1000. That means you are taking a value 1000 values from minus 5 to 5 for the plotting purpose. Now I have defined the variables. Now I have to write the formula, that is simple, 1 divided by root of, that is I have taken sigma first, 1 divided by sigma, which is defined, into square root of 2 pi into exponential of minus of x minus mu. You can write x or you can write y. If you write y here, then you have to define the y here itself, y minus mu y into, that is to the power of 2 divided by 2 into sigma to the power of 2. So I have defined the formula. Now I have to plot the graphs, that is x comma, this is x axis, this is y axis, and this is the color, and I am defining the line width as 2. Then I am giving the title Gaussian probability density function and giving the label x axis and giving the label for y-axis, and I need a grids in my graph plot, so I have given the grid on. So this is how you have to write the code for the Gaussian probability density function. Thank you.